This presentation will look at electrical circuits and connections. Okay, there's two sorts of electrical circuits. One is called a series circuit, and this is where your power supply and all of the components are connected in one loop or in a daisy chain fashion, or one after the other. And here's an example of an electric light globe and an ammeter hooked up in series in a circuit. The other type of circuit is parallel, and here's an example of a electric light and a voltmeter, and you can see they're not connected up in daisy chain or one after the other in one loop. There's actually two separate loops, and one loop piggybacks on the other. So this is what's called a parallel loop. In a series circuit, as we said, all the components are connected together to form one loop or pathway. And here we have a battery connected to two globes, and they're connected one after the other, and then the wire leaves the globes and goes back to the battery. And you can see the circuit on the side has the pathway, or the wire coming from the battery to the first globe, which goes to the second globe, which goes to the battery. When we have a series circuit like this, the energy that is given to the charge, or the voltage, is shared by both lights. In other words, they only get half the energy each, and because of that, they'll glow the same brightness, but it will be reduced than if there was just one globe. Parallel circuit is different, and we said that there's at least two loops or branches, and each branch has its own components. So here's an example of a parallel circuit with two globes. Instead of the globes being connected one after the other, they're connected in two separate loops. If you have a look at the circuit diagram on the side, you can see the battery, you can see the first loop containing a globe, and you can see the second loop containing a bulb as well. Now, the big difference here between a series is that these globes don't share the voltage. Each of them get the same voltage because they're connected in separate loops, which are piggybacked on one on the other. So it means that each globe gets the same energy that's supplied from the batteries. So each globe will glow the same, but it will glow twice as bright as two globes that are sitting in a series circuit, because they have to have half of 6 volts each, which is 3 volts, so they don't glow as brightly. Now, if we look at the energy, we can have a look at this picture. There's a graphic of a series circuit, and just notice how the energy is used while traveling through the globe. So we can just click that, and there you can see the energy going out of the battery, the little green dots, and when it gets to the globe, it's all used up, and they go back to the battery. So that is how a series circuit works. If we look at a parallel circuit, we've got the two globes here, but there are two separate loops. So if we have a look at what's happening, we can see that the same energy is going to each globe, but you can see here, particularly as they start to go from into one loop or the other, that the current is not as heavy as the series. So in fact, the current halves, or the amount of charge halves going to each loop, but the voltage is the same. So the energy is the same, and the globes glow just as bright as the single globe in the series. Let's have a look at how this works. So here's our energy being supplied to both bulbs in the parallel circuit, and because they're both getting 6 volts, it means they both glow brightly. And just remember that in the parallel circuit, if there's 2 loops, then half the current goes into each loop. If there's 3 loops and the components are the same, then a third of the current will go into each loop. Now, circuits in your home, it's interesting that circuits in your home are connected in parallel. So they can be independently controlled, and they're all supplied with 240 volts. So you can see at the top we have our power supply, and then there are parallel circuits going to the light, to the hairdryer, and to the TV. Each one of those is getting 240 volts, so it means that they'll work properly. It also means you can put a switch on each one so you can turn one on and off, because in a series circuit, if you put a switch in and turn one off, it turns them all off, where a parallel connection will allow you to control each one independently. Obviously, if they're all off, nothing will flow. Now, safety in the home's a big deal. And when someone or something shorts an electric circuit, it means that the electricity has an easier path to travel. Let's say little Johnny's trying to get his piece of toast out of the toaster, puts a metal knife in to try and get the toast out. Now, if he touches the metal, or the metal that's carrying the electricity, those hot bands in your toaster, it means that the electricity suddenly has an easy way to travel. The reason they're hot in the toaster is that there's a lot of resistance there, and they're using up lots of energy, and it's turning it into a heat. But if little Johnny puts a knife in there and connects it, it means suddenly the electricity's got an easier way to travel, and it will. Unfortunately, that means that little Johnny might get electrocuted. So, and the big problem is that other ways of getting electricity to travel in other paths than it should. It might connect to another wire. It might be a metal object like a little Johnny and his knife, or even water from the tap, or a flood, let's say. Or the other reason that the electricity might go a different direction is that, as we said, through electrocution of a person. So we want to keep this house really safe that this doesn't happen. How do we do that? Well, in older houses they used to have a wire that was called a fuse, and the fuse would heat up and actually break if the current rose to a certain level. Now what happens is that these electric fuses are set to a particular current, and if the current gets higher than that, the fuse blows. The same as if there's a short, it means that more current will flow because there's an easier way for electricity to flow, and too much current means it'll blow the fuse. Now newer houses have circuit breakers or safety switches. These devices, as we said, are rated to a level of current, and if the current rises above this level, let's say there's been a short, then they switch off the power. And in your circuit box you will see things like circuit breakers, and you might also see a safety switch, which most houses these days have, and that's specially put in to stop people being electrocuted, such as little Johnny putting his knife in the toaster. Sometimes you'll also see these switches on wall plugs, and it means that you can also have protection at the wall outlet level as well, and you can test it and also reset it, so turn it back on once it's gone off. So if there's a short or a malfunction with the equipment, it can actually be stopped right at the wall power outlet. So these are the things you'll need to remember about electrical circuits. Most important, the differences between a series and parallel, the difference between voltage and current, and how they are changed in both of those types of circuits. Also understanding that current is the way that these safety devices work, and it's by measuring the level of current. If it's above what they're set at, then they turn off and make the house safe.